essential questions on the notes. And we're going on chapter 4 here, guys. Chapter 4, we're going to still be working a lot on linear stuff, but we're going to kind of focus more on taking that linear idea and applying it to some real settings now. So, guys, 4.1 is entitled what we know as slope-intercept form. You already told me again, general form of slope-intercept was what? Y equals mx plus b, where m represents the slope, and b represented the y-intercept. Good. So goal for today, or I'm sorry, an essential question that we want to ask ourselves. Given a graph of a linear equation, how can we write an equation of the line, specifically slope-intercept form, and then use it in real life? So goals, we want to write equations in slope-intercept form, which I've highlighted again right here. That form is what we're dealing with. That's a pretty purple today. Or is that pink? Purple or pink? You tell me. Pink? How about I call it purple?
Oh, nice.
Purple?
It's definitely pink.
Pink? Okay.
Over there, I think it was pink, but on there, I think it was
Okay, cool. All right. We're also going to use linear equations to solve real-life problems like we set up here. So, guys, really quickly, slope-intercept forms again. A line or a linear equation of the form y equals mx plus b. So, as an example, maybe like y equals 1/2 x minus 3. Give me a show of hands, please. But what's the slope going to be in that example? We've already talked about this. What's the slope, Nolan? 1/2. And where are we going to start this? What's the y-intercept? Where would you start on the y-axis? -3. So we know this, all right? We also know what a function is, so we want to revisit that in this section. A function is going to be a rule that assigns at most one output for each input, okay? So we might try and recall function form. Also, that f of x, we always said if you ever see f of x, it's the same as setting it equal to what variable? The y variable. Guys okay there? Are we okay there? All right. And then finally, slope. Slope is going to be a rise over a run, or change in y over change in x. We've discussed that a lot this year. And we also had a formula when we were given 2 points. You guys recall that formula for slope? You guys recall that formula for slope? We did it in the last section. We had 2 points. We had some y values and some x values. You guys recall the formula for me for finding slope? Change y over change in x, which we denoted, very good, KB, denoted by y2 minus what? Over x2 minus x1. Okay, so that's what we were doing there, all right? Small things to recall there, things to know for the vocab. So let's jump into this. Example 1, very easy. Things are going to get progressively more difficult here as we move through the notes. But hey, here's the deal. Example 1 says, using slopes in the y-intercept to write a what? Equation. Okay. If they ever say, hey, I want you to write an equation for this section, I want you to think, all right, well, start out with a general formula. Y equals mx plus b. Our job today, find a value for the slope. Find a value for the slope. So we're going to find a value to plug in for m. Find a value for the intercept, a value to plug in for b. Our job today, find a value to plug in for m. Find a value to plug in for b. Find a value for m. So we really need to identify what the slope is and what the y-intercept is. I love these first examples. You know why? If I have to write an equation, what do you already know up here?
The slope.
The slope and the holy cow. That's slope. What variable are you going to plug that in for? It's going to take the place of m. This is my m value. All right. How about the y-intercept of being -1?
B.
That's your b value. Okay. Your job in this section, hear me out. Find a value for m. Find a value for b. That's really all we're doing. Once you've found those values, they want you to write your equation in slope-intercept form. So in slope-intercept form, what's this going to look like given these conditions up here? Y equals what?
3x plus negative, or minus 1.
Okay, so I can write 3x minus 1. Are we okay with that? That's all you're doing. So show of hands quickly on B. What's the equation going to look like in part B, KB? Y equals 1/2 x, you say? Do I need to put plus 0 on the end?
No.
Could I put plus 0 on the end?
Yes.
Okay. I could. All right. And maybe I should write it this way. Or I could say, you know what, we could write it as y equals 1/2 x plus 0. So if I give you a slope, I give you an intercept, can you write an equation in slope-intercept form?
Yes.
I hope so. All right. That might be the most simple thing we've done all year right there. Okay. Now again, the idea is that, hey, we're going to continue to write equations in slope-intercept form. All right. Now I believe I've provided some graphs for you on the part. Did you get that? Okay. It was 0 on the end of that, Mason. Okay. I think I provided graphs on page 2 already, haven't I? Can you guys tell me which points that we used on that first one? Can I just see somebody's graph here? I'll draw the lines. Can I see that one? Looks like to me I plotted this point. And this point. Let me get these drawn quickly for us and then we'll discuss them. Why don't you, while I'm working on here, see if you can't write an equation for the given lines in slope-intercept form as I'm putting them up here. Okay. Guys, again, what values am I trying to find numbers for? What variables are we looking to substitute for in our general form right up there? M and B. Okay. M representative of the slope. Guys, the 2 points I've highlighted on there, could you do a rise and run on the graph? What's the rise from point to point that's highlighted? Rise 1. So I'd rise 1 and run to the right how much?
3.
So what's that make the slope in this, guys? Yep, again, it rises 1, run is 3. And again, if I go back to the last section, if I talk about uphill graphs, downhill graphs, is this an uphill graph or downhill graph? Well, it's uphill, right? So then it's got to be a positive slope. How about the y-intercept? What is that? What is my y-intercept? 3. Okay, y-intercept is 3. So help me out here. What's the equation for this line going to be quickly? So y is going to equal 1/3 x. I'm listening, Kaylee. Plus 3. Excellent. All right, excellent. It's pretty easy, isn't it? Pretty easy. Again, we've kind of talked about this, and we're going to carry you through with some more stuff on this. But look at this slope again. My rise and my run. What kind of a slope will I have for this line? A negative slope. So help me count here from point to point that's highlighted. I think I'm counting 1, 2, 3, 4, 5. Is that 6 units right here, guys? Specifically, what kind of a 6, since we're moving downward? -6. And then your run. Is that 4, kiddos? Okay, so my slope, M. -6/4. Could I choose to reduce that or write that differently? What will that reduce to, Nolan? -3/2. Very good. And then how about the y-intercept? What is my y-intercept? -2. So to express the equation of this line in the coordinate plane In slope-intercept form, I'm going to write this as y equals negative 3 over 2x, and then minus 2. There it is, okay? So that was, you know, kind of the same thing as the first part. Again, you need the slope, you need the intercept. The first example given to you. Second one, hey, here's a graph. Can you find the slope? Can you find the y-intercept? Well, yeah, you can, and then just put stuff in appropriately, right? Okay, well, then we get into example 3, guys. And all of a sudden, instead of having a slope, do you guys see a slope anywhere here, guys? See a slope? I don't. Okay. Guys, I want to do something real quickly. Just pull up decimals here for a second. You don't need to do this. Guys, on example 3, it says we're going to write an equation in slope-intercept form. Write an equation in slope-intercept form, and I'm going to show you some shortcuts here, given 2 points. Okay, what was the first point that they put in there, kiddos? What's the first point they put in there? 0, comma 6, positive 6? Negative 6? All right, hey, I want to show you something right here. Whoops, I think I screwed that up, didn't I? Okay, when I typed in 0, negative 6, what do you notice down here? What do you notice right down, say, oop, no, I didn't want to do that. Nah. What do you notice right down here? What point is that? Negative 6. When I say 0, comma something, when I say 0, comma anything, which axis does it put that point on? What's on the y-axis? Isn't that negative 6 going to be my y-intercept? Okay? So I'm going to go back to the notes right here and say, well, since this is the point 0, comma negative 6, I'm going to make a note up here. 0, comma question mark. I'll put question mark up there. If I have 0, comma something, ever for a point, that just implies to you that the question mark, whatever that value is, that is your y-intercept. Okay? So maybe another way to write this is saying 0, comma question mark. Maybe I should write this as 0, comma b, because b is really what point? In the general formula, what's the b represent again? Y-intercept. So really, if you have 0, comma something, that second value is really your b value. So given this point right here, kids, what's that make your y-intercept in this problem? So I'm going to write b equal negative 6. Now, given 2 points, do you remember the formula to try and figure out the slope? y2 minus y1, x2 minus x1. This is my first point, point 1 here. So this will be point 1. This will be point 2. Again, we already know the intercept is negative 6. So my slope, help me out. Let's find the slope. Here we go. Second point, what's the y value? 9. First point, what's the y value? Negative 6. So 9 minus negative 6 for my change in y. Next, the x value, second point. 3 minus, okay, this is really 9 plus 6 up top. So what's in the numerator? 15. How about on the bottom? 15 over 3, we can simplify that nicely. What do we get for our slope? 5. Slope's 5. All right. What's the equation that passes through, actually back up, what's the linear equation, slope-intercept form that passes through 2 given points? Y equals, say it one more time, KB. Hey, I want to check something. And I think that you guys should do the same thing as well. And check this. I'm going to go back into decimals. Boom. I'm going to clean this up. I'm going to type in our equation. What was our equation again? What's that you say? Y equals again 5x minus 6. Here's the graph. I'll zoom home. I'll go projector mode. Hey, do I hit the point 0, comma negative 6 right down here? What was the other point they had suggested? 3, comma 9? Is that right?
Yeah.
Naughty. Alright, I'm going to try and hold still. Did you see 3, comma 9? Ah, come on. Ah! Well, you get it. 3, comma 9 did show up, right? Those 2 points were there, right? Okay. Alright, so hey, on your own, you guys try part B to this, alright? You try part B right here. First of all, I want to know what's the y-intercept value right off the bat, based on what I told you. Looking at these 2 points. The intercept has to be 2. Has to be 2. And I'm going to take somebody's equation right here. Type it in and see if it passes through the 2 given points. Anybody have a solution here? What's the y-intercept in this situation, kids? 2. What's the slope in this situation? What did you guys get for slope? Negative 3/4. You bet. The 2 minus the negative 1. 2 minus negative 1. 3 up top. And then 0 minus 4. The x2 minus the x1 on the bottom. I end up with that. So this is what I came up with. You tell me if I'm right. Negative 3/4 x plus 2. Is that what you guys came up with there?
Good question.
Yep.
So you always pull from the, like, does it matter what side you pull from first? So like on the thing it was.
As long as you go the
0
same direction
minus
each
4.
way. So if you went negative 1 minus 2 up top, as long as you went from left to right, you need to do the same with the x's. Left, right, 4 minus 0 on the bottom. Yes, that'll always work. Yes.
Okay.
Is that what you did?
Yeah.
Okay.
Well, I was gonna do that.
And you can do that. So in other words, you might have had the formula y1 minus y2 over x1 minus x2. Okay, that's acceptable. All right, I could graph that. I'm going to stop here. I'll let you guys know your test scores, and then I want to set up some time for the people that still need to finish that. So no assignment today.